The majority of our entering first graders typically use level 1 methods most of the time. And so early in the school year, we begin the process of fostering more advanced strategies in such a way that children develop the underlying and necessary cognitive structures. It's not enough for children to mimic how others count on. To use level 2 methods accurately, effectively, and independently in novel situations, children have to have made an intellectual leap. In this lesson, we explore the kinds of cognitive development that is necessary to make that transition, and we look at some examples of instructional experiences, as well as identifying some assessment implications. Counting on plays a role in both Standard 5 and Standard 6, with children understanding how counting can be related to addition and subtraction, understanding that deeply, and then also being able to recognize that the role that counting on plays strategically. And it continues to play a role strategically even once children get beyond their basic facts, because as you work with numbers, even larger numbers, let's say 327 plus 2, in that case, counting on is much more efficient than, let's say, the standard algorithm. In addition to that, counting on is worth fostering because of the fact that it supports children's intellectual development. Sewer and Lambert refer to counting on as, quote, a concept central to a child's mathematical future, end quote. And that's true for their development in the number strand. Getting an entire class of children to use counting on accurately and independently without your cues is quite a challenge. Let's explore the nature of this challenge so that we can be better appreciators of the cognitive journey that children undergo, better observers of their struggles, and capable of thinking with more nuance about the nature of the difficulties that we're observing, so that we can think on our feet better and consider what tasks and prompts might support children at their point of need. A number of prerequisites to Level 2 methods are embedded in the Kindergarten Common Core, so if your school has already aligned their curriculum, then children should have experienced instruction in these areas, and there should be some assessment data available so that you can see whether students have mastered these skills or not. Certainly, if students have trouble with these skills, then some immediate intervention early in the school year would be wise so that they can even have a chance at accessing the counting on that is going to be fostered in the classroom. In addition to those prerequisite skills, there's a number of other skills that have to kind of be put together in a child's mind as they're learning Level 2 strategies. The fingers play a different role. My younger daughter tended to use fingers a lot when she direct modeled, but she was still representing every physical quantity, and each finger stood for an item in a set, and then she combined fingers to find all. So she was still counting all. But in Count On, the fingers play a more abstract role because we tend to use them for keeping track of counts rather than merely being items in a set. So we have to know when to start counting, we have to know when to stop counting, and once we stop counting, we have to know where to find our answer. For example, take a look at the images on the right. The counting pattern that you see with the fingers, it's exactly the same for both of the equations listed above. But for the top equation, I have to recognize that my answer is in the last number word that I said out loud, which is 11. And in the bottom equation, I have to recognize that when I get to the target number of 11, I have to switch gears and count the number of fingers I used to find my answer. In Level 1 methods, I did not have that much to organize, plan, navigate, and consider. It was much more straightforward. So for Level 2, I've got to be much more savvy about navigating the number system from different start points and stop points. And I also have to recognize that all of this is possible because of one addend being embedded in the total. So in this particular example you see here, I have to recognize that the 7 is embedded in the total of 11. You may have already discovered some curious things when you try to teach children to count on. For example, you may find children who at times seem like they really have this counting on under control, and then other times for different tasks you talk to them and it's like they're clueless about what's going on. This is not at all uncommon. Researchers have found that children's capacity to count on is highly dependent on several variables. Those variables include the nature of the task. If children cannot see all of the items, they will be more inclined to count on than if they see all of the items. If they see all items, they just tend to go into count all. Some prompts serve as a bridge that can support the counting on, although it is important to recognize that if children count on only in response to your prompt, that would not be a good thing. It wouldn't be good for you to indicate they'd mastered counting on in an assessment situation. That's a false read because you prompted it. We need to keep in mind a lot of those variables when we assess children. What they're capable of doing with our support and what they're capable of doing on their own could be different things. Finally, if the amount to be added is small, they're more likely to count on than if you gave them too large quantities. We need to be prepared for counting on to take a while. In fact, it's going to take much longer than the 2 to 3 lesson sequence that curricula often allot for it. They're going to wobble around in that zone of proximal development for a while, so plan a long-term strategy. And I realize you cannot dedicate many lessons to this, but it can come up often in strategy shares, for example, even if your primary focus was something else. In addition to that, you can think about how to leverage all parts of your day, such as morning meeting, what kind of math centers you have available, what kind of warm-ups you might do for a class. I would suggest you think about all of those and how you can foster counting on. The first sign of counting on typically involves children counting on from the first addend provided, but as they develop a more robust understanding, they will begin to see some advantages in counting on from the larger value. It's more efficient, it's easier to keep track of your counts. Some of the children in your class will likely reach this aha before others, and so at that point you can have some interesting strategy share discussions, sort of like, oh, look how Dennis did it this way, but George did it this other way. Does that work? Can we do that? How does that work? And after listening to some of the children's ideas, you can actually model what's going on using something like a number path, for example. We'll take a look at some representations a little bit later that you can use to model these relationships. Children who are subtracting 14 minus 8 will be more inclined initially to want to count back than to count on. Counting back is harder to do, though, and it's also more error-prone. Imagine saying the alphabet backwards and comparing that to ease with which you say it in the forward sequence, and you'll get an idea of the challenge. It's helpful to support children in recognizing that you can count on or count back. So in the case of 14 minus 8, you could count back from 14 till you got to 8 and keep track of your counts. But you could just as easily start at 8 and count up to 14. It works both ways. Now, rather than just sort of giving this to children as a, hey, trust me, this works, it would be wise for them to really understand it. So if you have children some who counted up and some who counted back, that would make a great strategy share discussion. And again, you can support them in visualizing that both of these are possible by using something like a number path. Okay, we're going to take a really quick survey through some different instructional activities, and I'm not going to spend long on these because some of them I suspect will be familiar to you, but these are just examples of things that can be used to foster counting on. Certainly, you can begin your experiences with some rote counting, that forward counting with different target numbers to stop at. That should be reviewed from kindergarten, but it's still helpful. Money doesn't play a big role in the first grade Common Core. However, it still plays a role when it can support some of the curricular strands that you are to be working with. And in this case, counting coins can actually play a role with learning to count on. So you do kill 2 birds with 1 stone, I think the expression is. So in this case, if you use a nickel with pennies, then they can start counting from the nickel on. This is called 2 piles. So the child counts out 2 separate sets. They know how many are in each set because they're the one who counted it out. The 2 sets have a distance between them, some slight distance, and you ask them how many cubes do you think we'd have if we moved them to the whole pile. You don't actually move them to the whole pile. You just ask and see what they do. That would be an interesting assessment task. It seems like it would be pretty easy, but keep in mind that when all of the items are shown, children tend to use count all rather than count on. Quick images dot cards. These particular dot cards that you see in the images were actually created by Origo Education in their Big Box of Facts. I love that curriculum. It uses a lot of visual images to foster basic skills, basic facts. And they implant the idea with dot images and then shift to an abstract, and then they have all kinds of follow-up reinforcement activities as well. That resource is in the references here for this particular lesson, but you can also make homemade versions of these if you're not as lazy as I am in terms of creating them yourself. All right, number paths are a really excellent way of keeping track of where you are in the number system. I do want to briefly point out that the points on a line, number line, is not a good model for first grade. Research shows that children have some misconceptions about how that kind of number line works. So for kindergarten and first grade, the discrete number lines, such as the one you see here, which is also sometimes called a number path, is the recommended source. So here's an example of a visual image that can support children's counting on. And in this particular textbook that used this image, this was followed, there were 3 of these different images to see different ways of doing it. And this was followed up by some exercises where the children could try it for themselves on a number line. Counters in a cup, you put so many counters inside a cup, they're hidden from view, and there's a numeral label. And then there's another set that the child builds outside, and they have to figure out how many there are altogether. This compare game involves rolling 2 dice, and each partner rolls 2 dice. They create the sum of their dice and then compare the answer to find out who has more. In this case, when children first start this game, I put stickers on dice so that the dot dice has 1, 2, or 3 dots only, again to use the idea from research that children are more inclined to count on when the number to count on is small. And then I can use numeral dice for the other value. A floor tile path, in this example you actually use floor tiles. If your classroom is tiled, you can also just use tape to like masking tape to create a path, but this is one that's big enough for a child to navigate. And a child rolls a die or a spinner, and then they move a certain amount, then they do it again, move another amount, and then they have to figure out where they are. How many total moves did they make? Keep in mind there's no numerals on this number line. So again, they may want to just count squares, and you can say, how can you do it without counting the squares? And so that's another example of something that children can do to foster counting on. Calendar questions during morning meeting lend themselves to counting on because oftentimes there's an event they're looking forward to that's just a few days away. So if this is March 17th and something that we're looking forward to happens on March 23rd, then how many days is that? What could we do? Missing addend problems, or change unknown would be an example of a missing addend problem, is they lend themselves to counting on because you see that you're at one place and then how many does it take to get to the next place. So the whole problem structure lends itself to counting on. And again, you can utilize some of what we know from research, which includes this idea that children are more inclined to count on if the change unknown or the missing addend is small. So again, you can use that kind of structure to facilitate counting on. Here's an example of some of the representations you can use with children to help them see what's going on. And the first 2 that you see off to the left are similar. One's a number path and the other one's called a tape diagram or a bar model. But in this case, both of those 2 on the left represent some nice things that you can show children. If some of the students in your classroom are counting all and some are counting on, then this model shows the students the difference. Okay, this student counted out the original set of 7, whereas the other person just sort of put their hand over that whole section and said 7. And then moved on. And so you can actually use these models to help children follow different children's strategy. The number bond is a little bit more abstract than that. It doesn't quite show that same, if a person's counting all, they don't necessarily connect that. Okay, let's take a look at some of the assessment implications for counting on. As you observe your learners in some of the above tasks that we just talked about, or similar tasks that perhaps are provided by your own curriculum, it's important to know what to look for. In the next section, we're going to examine some of the considerations in light of the research on children's cognitive development and counting on. First, despite the way the curriculum is set up, counting on is really not the sort of skill that can be taught in a 2 to 3 lesson sequence. So while your entire curriculum for a quarter can't be dedicated to just that one skill, it would be wise to employ all of these different many areas of the lesson that we talked about, such as mini lesson warm-ups, center activities, calendar time, morning meeting time, so that you can foster counting on over a longer period of time. Also, if we see a child successfully count on, it would be dangerous to immediately mark off on some assessment list that they've mastered that skill. Remember that there are many task-dependent and prompt-dependent features to success, so we really have to be careful about making an assumption that children have just mastered that skill and can count on spontaneously and independently on all occasions where it would be helpful. When children are not able to count on successfully, we also need to be thoughtful about the nature of those difficulties and try to focus our prompts to be just on the area of struggle. Instead of giving a lot of prompts, we want to give them fewer but more targeted to their point of struggle. These categories are helpful because they allow us to see where children are in terms of developing counting on. At the lowest level, we have children who persist in counting all. They don't appear to be counting on. Then we have children who can start out counting on when the activity is familiar or when there's a prompt to do so, but they don't necessarily choose to do that on their own. They have to be prompted. Eventually, the child learner may start to anticipate when to count on and what number even they could start counting on from without outside support. However, she may still be struggling with how to get stopped at the right point or how to keep track, the demands of keeping track of where she is in her count in order to stop. That would be another point of development where she's got the start part figured out but has trouble navigating the stop. At first, she may find success through being prompted, though. So if you find a child who, at that point, you can give a prompt and they're able to get past that, then we call it the activity-dependent stop at. But eventually, they may be able to stop, figure out on their own, and sort of prompt themselves and to think through, how do I know where to stop? Finally, when they are able to coordinate all of this, I know what task to use it for. I don't need to be prompted. I can actually come up with a plan for how to start my count and proceed. I don't have to be prompted. I can proceed. I know how to keep track of what I'm doing, and I know how to stop at the right value, and I know how to find out my answer. That's the well-coordinated counting on, and that's when you can finally say they've mastered it. But those steps allow you to kind of see that there's any number of places where a child can begin to illustrate struggle, and these are sequenced where the lowest stage of development is at the top and the highest is at the bottom. Because children are often able to use a previous task to help support them on subsequent tasks, you have to factor that into your assessment plan. To really know whether students are able to count on, you have to know what they can do without prompting. So in this situation, it's actually better to start with harder tasks that have fewer prompts and see how the children deal with that. And then as you gather information, you can begin to develop some hypotheses about the nature of the difficulties you're observing, and you can watch them in a counting activity to see whether that hypothesis is being strengthened. And then based on that, you can decide what prompts might support them, what tasks might support them, and record the kind of prompts that you used in your progress monitoring so that it's clear what students are able to do on their own and what kind of support they needed. Remember that too many prompts can actually hinder progress by preventing a child from developing decision-making skills that allow them to spontaneously use systems of keeping track, deciding where to start and where to stop. So that's why it's important to, instead of giving a lot of prompts that continually kind of micromanage their counting on, to be much more thoughtful about what can they do on their own, and then what's the least amount of support and prompting that I can do to get them to that point. As we choose prompts, it is very helpful for us to be more attentive to where is this child mathematically. What kind of mathematics are they constructing in their mind right now? Then our focus being on success. It isn't just get them through this task. It's what mathematics are they grappling with through this task? That's where our prompt needs to be located. As Zuhr and Lambert said in their study of how children make this transition, it is dependent on the critical interplay between the tasks used and the mathematics of the child. So our prompts then should really help the learner ponder the mathematical aspects of the task rather than seeing it as just very pragmatic, let's get you through this task. Quite a number of references guided this, and if you have considerably more interest in it, then I strongly recommend